Everyone for joining us today for a presentation on Oracle Golden Gate. We're going to cover some topics relative to some of the things we've seen as a consultant and managed services provider, so hopefully we can share that with you and be helpful. A little background on Neovera. We're actually a hosting solutions and services provider. We specialize in managed services, data center services, and enterprise cloud solutions. We have a wide range of organizations that we support, from smaller B2B companies to Fortune 500 companies to nonprofits. Founded in 2001. We're headquartered in Reston, Virginia. Our data center there, we're vendor agnostic. We have an on-site NOC 24/7 inside the data center. And we bring a wide range of skill sets and backgrounds as part of our managed services. A little bit about my background. I'm an Oracle certified professional, been fooling with Oracle since version 7. I've been in roles of database administrator, data modelers, data architects, just about every facet of the different industries. Actually hold a patent for healthcare predictive analysis software. I do speaking and presentations at various Oracle users groups, some more yearly training days, and I've also taught classes for Oracle PL SQL and all the DBA courses. Some of the environments that I've worked in, standard edition all the way to enterprise edition, rack, multiple 6-node rack environment with active to another data center, some rack over WAN within a data center complex, and those databases pretty much covered everything from OLTP to data marts, data stores, things like that. Just a little ground rule, we'll take questions at the end. If you'll type your questions in the little question box, we'll be able to take those and answer those at the end so everyone can benefit from everyone else's questions. A little bit of an overview. We're going to cover some of the Golden Gate actual overview of the architecture, some of the options for deployment. We'll cover some of the use cases for those deployments that we've seen and some of the issues that we've seen with those client experiences. And then we'll cover a little bit of the Oracle Golden Gate 12c, some new features in that, and actually some performance increases. So if you haven't seen this already, if you're not familiar with Golden Gate, this is pretty standard logical architecture of how this could be laid out. You have a source database. One of the processes that runs on the source and the target side is a manager. That's what does the communication setup, the ports for communication across the network. There's an extract process which is responsible for getting all the transactions from the source database and saving those, in this case, in the optional diagram flow, saving it to what they call a trail file. Basically, it's a file of every single transaction, what type of transaction it was, and the data needed either before images and what was actually changed, so that that can go over to the target side and be applied. That process is called a pump that'll read that local trail file and ship it to the target side. That is an optional process, so you could actually go from source straight over to target and have the target apply those transactions. Most people will create the pump, and the main reason for that is network outages. So the extract does not get backlogged on extracting transactions from the source. So irregardless of the network going down, the extract is still running. You're less likelihood that you would have to go back to old archived logs to mine those to get the transactions. And then once the network comes back up, the pump process could then ship those transactions over to the remote site. And on the remote site, there's a Replication process that reads the transactions that were shipped from the source and then applies those in the order that they were received into the target database. There's a little variations with that it can deviate from basically being serial, but for the most part, it's going to ensure the integrity of the transactions as they occurred on the source system. So again, this is a big picture of the logical architecture. Some of the topologies that we've seen, or you can actually deploy this in, is unidirectional, one of the most common, I guess, that we've seen, where people design this to where they can offload from their production system to another system exclusively used for reportings, or taking your backups from that system rather than production, and also to create a live standby. And so the live standby is similar to the bidirectional in the sense that it goes both ways, but only one way at a time. And then bidirectional is where you're going to create an active-active. This is where you might load balance web servers across multiple databases and also give you a little bit of high availability. Some other ones are peer-to-peer. So this would be the case for either load balancing or high availability, but this is primarily used when you might have multiple data centers in different regions, and all three of those data centers will stay in sync with the replication. And then broadcast is where you can take it from a single source and push that out to either regional databases for data distribution, and we'll see some examples where how you might use this even to build siloed data marts, or regional data marts, data warehouses, things like that. And then consolidation. That's where you're going to take multiple sites and bring it into a single source, build a single source of truth, if you will, build data warehouses, data marts, operational data stores. So this place where dashboards, executive dashboards and things can be created from all the different remote sites. And then cascading. This is where you might do database tiering. So you may ship it to, in this case, let's say we ship source to target, and that is our reporting. Target ships to remote sites for database tiering, in this sense that each one of these could be in a different region. And then those regions operate locally off of their databases. And in this case, this often seen where they subset the data. So coming from the source of the target and then propagated out, that is usually filtered, and there's subsets of data relative to that application at that site. Some of the supported data sources, if you're not familiar with it, Oracle, MySQL, HP Nonstop, DB2, SQL Server. So some of the major players are more common databases. You can set these up as source and targets. So upgrades from one database to another vendor, or upgrades within the same vendor. Most of the things we're going to cover today are going to be centered around the Oracle product, not some of the others. But they all apply. Same concepts apply. The only differences are there are syntactical differences in setting up Golden Gate when working with specific vendors. So if you're not familiar with the installation process, it's one of the most easiest of Oracle software. You basically download a file, unzip it and untar it, create a Golden Gate user with the proper permissions needed, depending on whether or not you're doing unidirectional or bidirectional. Create the subdirectories. This is where Golden Gate's going to store all its report files, its parameter files, data files for the extract processes. Ensure that your database meets certain prerequisites. In this case, archive log mode, force logging. Now, I mentioned in a database or table space, there are cases where you may not want to force logging at the entire database. An example might be in some data warehouse scenarios or data marts, but you want it, at a minimum, you should be at least logging an entire table space then. So you don't have to do the whole database if you're only coming after a subset of the data to be replicated to the target. And then you must turn on supplemental logging. This is going to allow Oracle to capture additional column information that it needs for the updates, primarily for the updates. And then if you're going to use integrated capture, which I would highly recommend, then you should be sizing your streams pool. Some tests that we've done, where memory, most often DBAs will set the memory target and let Oracle control all the settings. And Oracle will size that streams pool up as it's needed, but the lag on that and the performance hit while it ramps up can be substantial. So we recommend sizing that right from the get-go if you're going to be using the integrated capture. Now, most of all the things I'm going to talk about is at least 11.203 database and above. We'll talk about 11.204 and what that might bring you if you're going to use, especially if you're going to use the new Oracle 12c Golden Gate. So one of the things, the very first steps in implementing Golden Gate is to do some initial loads. So you have a target, you have a source, you create a target database. You can use Data Pump to export the data and import it in, and then basically create that as your instantiation point and replicate changes from there going forward. Or you can let Oracle Golden Gate do it, the actual initial load. So all you need on the target is the actual structures, the DDL structures, and Golden Gate will then, with the right parameter files, extract the data out, read it, and load it all into the target database. And then from that point, it stops, it's done, and the regular extracts take over and pick up transactions that may have occurred while this process was running. So there's a little bit of intelligence in that. If your database is small enough, that's something that's easy to do, a little effort, as opposed to doing all the exports, imports, and making sure you start your extracts at the right point in time so you don't lose transactions during the initial load. I listed this here where we loaded 500,000 records. One of the things I wanted to list here to kind of show you, if you're using the Golden Gate to do the initial data load, that expect the size of the data that's going to be transmitted to be substantially larger than the actual table itself. So in this case, 500,000 rows, 113 meg, and the trail file turned out to be 252 meg for that. So there's a lot of extra data that's going in these trail files over and above the size of the raw table itself. So you have to account for that when you're doing these initial loads. So it's not something you would do for a 200 gig database, obviously. This is how simple it can be with the initial load with Golden Gate. On the source side, you add this extract, you give it an extract group name. You tell it that the source is going to be the table, start it. That starts the actual process of shipping the records over. And by the way, this goes directly over to the target database. It doesn't go through the pump process. So this is direct from source, direct to target. And you can, if you're familiar with Golden Gate with some of the commands, the info will show you what the statuses of extracts and replicates processes. But for extracts on initial loads and replicates, you can't see that with the info all. They just don't show up. So you have to actually say info extract group name tasks. And when you do the tasks, it'll actually show you those individual tasks. Otherwise, you would never see it in an info all. And then same thing on the target side, you add the replicate, and you tell it it's a special run, and start it. And now these two will communicate, the data will go across, and once it's all done, that basically stops on all the way through. So very simple, again, if you're going to do smaller data loads. So one of the things we're going to touch on is subsetting of data, whether it's superset to subset or subset to superset. In this case, I'm kind of showing that if you have an extract data source and its structure, you can see on the side there under source, there's 6 columns there, and you want to replicate that to a target that has additional columns. You can do that without going through some extra work in Golden Gate, as long as those columns match up in order. So in this case, you see where the target is good, there's two additional columns in this table, a previous last name and first name, that will replicate over, and we'll see how I'm going to actually make use of that in the target. But if you didn't do anything with those extra 2 columns, the data will still come over and populate that table. What you can't do is under target bad, where you see even though it's the same names from the source, the same physical names match up in the target, but they're not in the right order, that will not work. Excuse me. That requires you to create a source definition file. And we'll talk about the source definition file. So some of the use cases, I'm going to run through a few of them that we've dealt with. In this case, a multiple to single. So this is a case where we have 3 different databases. So this is maybe an example of the consolidation topology. But we have 3 different sites, and we want to replicate all 3 of those sites to a central database, retaining all the values of those. So in this case, you can see site 1 has some data, site 2 has, it's a different, this is patient information, and site 3 has a patient information. This guy goes to all 3 sites. These could be, all 3 sites within the same regional area in this case. And then we have the actual Golden Gate commands to do this. And in the first one, it's pretty simple for site 1. It maps over, and we're actually telling it to populate those extra 2 columns with the previous last name and previous first name by retrieving from the trail files the before image of that name that was changed. So in the case where we ship over a name change, we'll have the before value and we'll have the current value that's going to be applied to the table. And we're going to use those before values to populate the other 2 extra columns in this table. Additionally, from site 2, you can see where the names are lowercase. You can actually apply functions to the data as part of that applying to the target system. So in this case, in site 2, we've told it that the data we're going to get from that for the names is always lowercase, but we want to standardize in the data mart or data store, let's say, and we want that to be uppercase. So you can apply functions, and there's dozens of functions that you could use for this, but this is a string upper function. So we're going to just upper the actual last name that comes in and the first name that comes in, and then populate the 2 extra values. And then in site 3, we get the data in mixed case. Again, we want to standardize, so we uppercase it, the patient's last name and first name. And again, the same previous and before. So it's not just what you get from the source is what has to go to the target. You can actually apply some transformations to this. And most people don't look at Golden Gate as an ETL tool, but there really are a lot of ETL type functions built into the product that you can use it for. And I'm going to show you an example of how we actually can make use of that ETL functionality. So further on this multiple to single, you can see where site 1 does an insert, and then site 1 does an update. With that mapping we had before using those previous columns, we'll actually insert into the actual patient table on the data mart side. We'll insert the value, and then as soon as we get an update, we'll actually update that record, but then record the previous value. So in this case, we're maintaining something like a dimensional type table for a patient. On the site 2, where we got the lowercase names, you can see where original record, all lowercase, an update was done to the first name using the ETL transformation type functions to uppercase that. You can see what we get into the patient table on the target, and we also capture what the name was prior to the update. So we can kind of keep a little bit of a historical record along with this. This could be extended, obviously, to capture all values. If you were building, let's say, a dimension where you, not necessarily like a slowly changing dimension, but one that recorded the previous values in the same dimensional record, you could get that information from the trail records. Now, what we talked about was if they don't match. If you're going for a live reporting system, chances are they probably will match. But if you're going to a system where you're going to be aggregating data, or you're going to be changing the structures of the table that data is going to reside in, then you need to do a source definitions file. A source definitions file is basically, it records the columns, the data types and things from the source system. So in this case, you create a definition file by running this def-gen utility. Inside the parameter file, you basically tell them what tables you want to generate the source definition for. That creates a definition file. That definition file then gets shipped over to the target system, and the target makes use of that definitions file as part of its replication process. So when it goes to apply the information, it looks at the source definition file, brings that in, and now it can use all that information to do the mappings. Here's another case where we do a dimension. We build a dimension. So in the original slides I had where we loaded some flight data, source record 500,000 rows. This is a record of all the flights in the United States in a given month. So that was our source system. From that, we are building on the fly a date dimension and a origin dimension, where the flight originated from. So basically, out of those 509,000, they were all for 1 month. So we would get a dimension that would actually have 31 entries in the dimension. We'll ignore the updates because out of the 500,000, there's going to be lots of duplicates of the year, month, quarter, day. So we basically are discarding the duplicates and inserting the single record. So once the first one goes in, all the others are ignored. Now, in this case, we actually changed the value of one of the columns. So this source had FL, flight date. We want that to be our key for our date dimension. So in this case, we have a date key to flight date mapping. And again, the use defaults is if it finds columns that match in the same data type and the same order and the same name, then it'll just automatically map those. We don't have to spell out each individual field. We can just call out the ones that are different. And the same thing for the origin dimension, where we ignore all the duplicates and build a dimension on the fly as source records come in. And remapping the actual origin key from the original origin airport ID. Another case where you might want to do a pivot table. In this case, we have 3 sites replicating product information. So all 3 sites have the exact same product, this product table. This information then comes into a target, and what we're wanting to do is pivot all the target site data into one single row for that product. So we're going to take a single table, product table, and put 1 row for each product with totals from each site. So you can see we have the actual individual column, store 1, store 2, store 3 values, and then we also have some computed columns in addition to that. So all 3 records will come in, and each one will update the specific columns for that site for that particular product ID. And this is what a mapping looks like to be able to accomplish that for one of the stores. So this would be replicated 3 times in your replicate file, depending on how you structure it, if you had a single replicate parameter file. So I'm going to go through this a little bit. So we're going to map store 1's product to store product. So we're going to have store 1, store 2, store 3, all going to come into a single store product table. We're going to insert any missing updates that may occur. So this is the case where the record doesn't exist at all. This is the case where if store 1's already created the product ID and store 2's coming in, it needs to be able to handle those updates when there's no data there for those columns. As part of this, we do a lookup. This is a SQL exec, so you can execute commands, execute a query. In this case, I'm getting the actual on hand and the quantity sold columns from the other 2 stores. So when I update store 1's value for that product, I want to capture what the store 2 and 3's on hand and quantity sold is, and I'm going to use that later to actually populate the computed columns. And in this case, we're passing it a parameter, the product ID, which is coming from the trail file. And then we resolve conflicts by doing insert row exists, we overwrite. And in the column mapping, we show each column that's being mapped. So in this case, product ID to product ID, that stays the same. store one on hand, which was the column, is now going to equal, or is the column in the target is now equal to the on hand coming from the transactional record. Same thing for quantity sold and DML timestamp. And then for the two computed columns, we actually evaluate the return values of the query. So the previous SQL exec, we look and say, what was the value from one of those columns? And if it's greater than 0, then I want you to go ahead and take the on hand and add it to the total on hand and put that in the column for total on hand. So it kind of adds up as it goes along. And the same thing for quantity sold. It looks at those total columns and inserts new values. So it maintains that on the fly as it's running. Obviously, there's other ways of doing it, but I wanted to show some of the features of what you can use functions and some sort of logical statements to look at the information you're getting. You can actually query the database to see what's already there and use that information to actually make a mapping, set a conflict, store a new value, things like that. So it's powerful in that respect. All right, so one of the things we've seen clients that fool with the get truncate. So in the cases where you may have source and target and the source is truncating the table and reloading, and maybe it's not a significant amount of data, and you don't want that to go over to, either you do or do not want that to go over to your target system and do the same thing, this parameter controls that. So you can include it in the extract file. So the actual truncate table command will go into the trail file, and then that'll get shipped over to the target system. And at that point, you have control as to what you want to do with that command. You can actually ignore them. You can actually process it. So in this case, you know, if you put it in the extract and you don't put it in the replicat, you know, it'll be captured but not processed. And so the downside of that is, depending on how you capture and deal with that, you could end up with duplicate records in your table. So truncate comes over, if you ignore it and you already had records in there, they could come in again. So these are things as part of conflict resolution that you have to deal with. It can actually be processed by the replicat even if you're not using DDL support. So if you're not using bidirectional and you're using unidirectional and you're sending truncates over and you want that truncate to occur, or you want to know about that truncate, you can actually handle it. If you're going to replicate that truncate command, there are some special privileges required for that replicat user to be able to alter that table. And that's in some of the documentation for doing truncates without DDL support enabled. Or you can actually execute the truncate through a store procedure. So if you don't have the permissions, you can call a store procedure that'll actually trap the truncate and apply a truncate. So in this case, I'm giving an example of that where it actually says, okay, exceptions only, which is on the truncate of data loading for the flight data. We're going to execute a store procedure that actually does the truncate table as an execute immediate in it, and we pass it the actual table name. So kind of a generic procedure, gets a table name and actually performs the truncate on it. You can actually say, I don't want it to happen, but I want to know about it. You can actually append, in this case, we're appending a message to the error log table for Golden Gate. So in the case where we get the exception, we call it an event action, and we actually shell out and echo this line, which is user-defined error, and we pass it in the date, the actual operation type, and the table name. In this case, it would be truncate. And that will actually go into the error log. So if you're monitoring the error logs, you can now put things in there based on actions of your replication process. And we'll talk about the event actions a little later. That's actually pretty powerful that not a whole lot of people actually make use of. So for the get truncates, I want to show you what it kind of looks like in a trail file. This is very similar to what all the DML activity would look like inside, our DDL look like inside of a trail file. There's a header section, which is the top part there. You can actually see it's labeled as a GGS purge data. That's the actual word for truncate in Golden Gate for detecting it. And you can actually see at what log completion CSN and transaction ID did that. That'll be important later if you decide that you don't want this truncate to occur, but you need to finish processing everything else in the trail file. So if your process stops and gets the error because you didn't handle it, there's a way you can get around this. And this is some of the information that you would need to know in order to do that. And the way we do that is to skip that transaction. So if you have 1,000 inserts and then a truncate and then 1,000 inserts and you didn't handle the truncate, the first 1,000 will go in, the truncate caused the Replicat to stop. And it'll say, okay, I don't know what to do with this. What you can do is actually determine that RBA for that transaction. In this case, if you do an info on it, you can actually see the RBA number that it hit for the truncate and stopped. You can also do a show CH, and that'll actually show you the actual RBA and what trail file, things like that it was in. We could use this information later if we want to do a more complicated way of skipping a transaction. To get that actual data that I showed you on the previous screen, we use the log dump utility. So I use that log dump utility in this case to find what's the next transaction if I wanted to skip past this one and go to the next one, which would be the next set of inserts. So when you use log dump utility, you basically are opening up a trail file produced by the extract process. You tell it where you want to position. In this case, I'm positioning based on that RBA number. That takes me to that RBA number in the trail file. I can see, okay, that's the purge data for that table name. Go to the next transaction. The very next one is an insert, and that's where I want to restart this process at. So I'm going to skip over the truncate and restart. And the commands on the Golden Gate side is basically alter the Replicat. You can give it a new RBA number, which is the one for the insert, and then restart. And that will skip over the truncate and continue processing all your inserts. This is assuming you've either decided that that truncate wasn't needed and it's not going to cause additional primary key constraints when you restart the Replicat. The most simplest way, of course, though, is to actually just start the Replicat and tell it to skip the truncate transaction. So if you know that when that process appended, that is the transaction for the truncate, you can simply start it saying skip transaction. That will jump right past that and continue on with the rest of the transactions. You can also specify specifically which CSN number. So let's say there was a truncate, maybe a couple of truncates in there, and you needed to skip past 4 or 5 of them. Instead of running the skip transaction 4 or 5 times, you can find that CSN number in the trail file and go directly to it and run with that. You can, and by the way, I showed 2 different syntaxes here. You can say start with the one after it, which is the truncate one, or you can start at SEN, which is a specific transaction within the trail file. So either of these 3 or 4 methods will work. One of the other common things we run into is when someone has set up unidirectional and they're using it as a live standby. So this is a case where you're primarily going to one site, but in the event of a failure or maintenance, you want to switch over to a live standby, which wasn't previously being used, but it's all set up to replicate or extract and send back to the source, from the target back to the source. There's always some confusion as to how you should do this, in what order, but from a high level, basically on the primary system, you want to stop the application. You verify that the extract processes have processed everything that's pending and there's no longer any transactions in it. Verify that and this goes for the pump as well, because you want to make sure the pump actually reads what was extracted and sends to the target. Once all of those show into file, you can stop those. And on the standby, verify that the Replicat has applied all the pending transactions that came from the source. So now you've verified all the way through that every transaction in the pipeline is applied and there's nothing pending. You stop it. Now you can turn on the extracts that were on the live standby and tell it, okay, I want you to begin now. start, and by begin now meaning capture every transaction that occurs from at this point forward. And then your applications can then hit the live standby system. And at that point on the live standby, all the transactions are coming into it. It now is capturing all those extract records and sending those, or can send those over to the primary. However, in between that, before you start everything back up to send, this is where you're doing the maintenance on the primary. So however long that's down, you're doing your maintenance, you're done with the maintenance. This live standby has been capturing while this maintenance is going on. You now start up the pump extract that ships it over to the primary, and then you start the apply process on the primary. And so it applies all those transactions. So now it's kind of the role reversal or role switch scenario. And in the same way, you reverse this all to go back again, to get them off the live standby and go back to the primary. And I'm going to show you some other things later on that kind of can automate this that people don't take advantage of. Again, this is with the event actions. In this case, if you want to trigger some of these processes to stop and start automatically, you can actually do that with the event actions. The event actions can be applied at a table level. They can also be applied at the entire Replicat process level. So you can call procedures. You can call procedures on a schedule. So you can basically run a database command or call a procedure query every 10 minutes if you wanted to look for something, to perform an action. But most often you'll have it in the map statements for a specific table. And in this case, you create a table, and this table is what's going to drive the events that flow through the system. And it only needs 2 columns. It needs a primary key column and some sort of description or column to hold a value that you're going to later filter on. Add that table to your extracts, add the trans data if needed. If you're using schema tran data, you wouldn't need to do that. And then on the standby, add that table to the standby, add that table to the parameter file so that it can pick it up from the extract. And now you add a filter and a trap event on it. So what we're going to do is look for a value that comes from the primary. We're, in this case, a process status table. And in the target, we never actually apply this record, but we use it to take an action. And in this case, we get the record, comes in, we filter on the description. It says switchover, and we take an action to ignore that transaction and stop the Replicat process. So as part of your switchover process, you shut down your applications. You then update a record inside the source table saying switchover. That transaction gets extracted. That extracts gets sent to the pump, then gets sent to the target. The target sees it and says, okay, this is telling me to take an action to stop the Replicat. If that's the last transaction as part of your switchover, now your Replicat all the way through is clean, and it'll shut itself down automatically. And you can do this. There's starts, there's suspends, there's ignores, there's like a dozen commands that you can issue as part of event actions. So something a lot of people don't take advantage of, but it's a very good one. Monitoring, this is another issue where people just kind of lost as to whether or not records are in their target system, and how long does it take, how long will it take, things like that. So the lag on the Replicat side is measured in seconds between when the last record was processed and the timestamp in the trail file. So this timestamp that occurs in the trim file, so it's not the time from the very source commit on the source system, it's when it actually made it through to the point where it got recorded in the trail file, and now we're looking at it's been sitting in the trail file for the X number of seconds. Is basically what you're getting from the lag. You can run 2 different commands. They output the exact same thing, the send, get lag, or just say lag on the process. You can also check the lag using the checkpoint table. So as part of creating the installation, you create a checkpoint table on your target system. You can query that and get the same exact information that the lag gives you with a query. So you could actually write a DBMS scheduler process that looks at that and sends out an alert based on thresholds if you wanted. The other thing you want to make use of is a heartbeat and heartbeat history tables. That's so you can get the current lag right now and to track lag over time. There's a MetaLink document that describes that, although we've made it much more simpler. I thought it was a little bit more complicated than it needed to be, but it is there for you to implement. Or you can use the director or the Oracle OEM plugin and monitor it from there. You also, as part of monitoring, want to make sure you monitor process status. This covers the manager, the extracts, the replicates. You want to be looking at your error logs, your report files, your especially discard files. Most people don't look at discard files, but if you've set up error handling and you've discarded a record and you're not paying attention to that, those go unnoticed almost indefinitely. So we often find people don't really monitor their discard files when they should be. You can also use Veridata or an in-house scripts if you're going to do verification at the data level. Also, if you're 11.203 above, you can use the Performance Advisor. So it's a package, SP-ADV. It's Streams Performance Advisor, and get some pretty good statistics on what's happening within the process. If you're using the integrated capture. And there's also, if you're 11.204, a really nice health check report that runs and actually looks at all the processes within the infrastructure for Golden Gate, and then can report back if there's any problems it sees or performance issues there. And if you're lucky to be on Oracle Database 12c, you actually get all these statistics now in the AWR report. There's a whole section, a dozen or more statistics related directly to Golden Gate. Oh, Golden Gate 12c, I'm just going to run through and just kind of show you. It's the same look and feel now. It's not the same. It's not the unzip and untar, as easy as that was. This is actually not so bad either. You can see there's only 5 screens. It uses the same look and feel as your Oracle Database software installer. These are the 2 options for installation, 12c or 11g. You tell it where you want everything to be located as far as the Golden Gate software. You can check to start the manager on installation or not. If you have a previous Golden Gate running and you want to install 12c without affecting it, you do not want to check that start manager, because the start manager will actually start up the manager. And if you have the same ports and all, unless you specify different ports, it's going to start a manager, that manager for 12c instead. You could break your 11. Also, if you check the start manager, you will get all the subdirectories. So all these different directories for the report files and parameter files, those are automatically created by the installer now. You don't have to create subdirs as part of the installation like you did in 11. Same look and feel, like I said. You get a screen that says a summary, and then it does the install. And it literally takes just a few minutes at most. After the install, you run the ggSCI command, and you'll see that you're on version 12.1.2, whatever. This is the latest one downloaded from MetaLink. Again, if you choose to start the manager during installation, it will create the manager parameter file for you, but it only creates it with just a port, and that's it, nothing else. And obviously, that's not good enough for production systems. There's a lot of other things that you would have in your manager to maintain in Golden Gate environment. Also, now that you've upgraded to 12c Golden Gate and now you want to deploy that, you need to do some additional steps on your database. You now have to set the alter system enable Golden Gate replication equal true. So it's a new parameter. Again, to use this, to use 12c, you need to be at 11.204. So this is 11.204 parameter that was introduced. If you don't set this and you try to start up your processes after installation, you're going to get Golden Gate replications not enabled. You're going to get an error in your process. You also want to take in consideration your undue retention. So if you think that there's going to be transactions that might be out there for a long time, you may want to up that parameter. And also highly recommended set your streams pool size. So with 12c and 11.204 combination, recommendation is a gig per extract replicate with about 25% overhead. So in this case, you're running 2 extracts, you're looking at 2.5 gig, you should be setting your streams pool size. I've seen where it actually doesn't use 1 gig. Some of the processing I've seen uses like 3, 4, 500 meg, but it really depends on the amount of data you're pushing through. And interestingly enough, for Golden Gate 12c, the permissions requirements list that the user needs to have DBA privilege. I haven't tested revoking that and figuring out which individual ones are, but it's interesting that it's actually listed as now that user needs DBA privilege. And for most DBAs, they're going to have a problem with that, or at least try to figure out what the permissions are. Again, integrated capture now is kind of enhanced from the 11 version. So if you're on 11.204, you have like what they call this full support for integrated capture. It now interacts with the LogMiner server to receive those LCRs, but it doesn't require no triggers, tables, or other database objects to be installed. So if you're doing this DDL replication, you don't need all that. You don't need to run the scripts to do all the DDL setup for creating the DML triggers and things like that. Same thing on the Replicat side, integrated. DDL is applied directly by the Replicat. It constructs all those change records from the trail file. It actually attaches, what's new in this process, it attaches to some background processes via a lightweight API, and then runs it through a process to read it, schedule it, coordination, apply it, and this is for parallelization. So now these transactions can all be distributed and applied in parallel. Greatly simplifies if you were doing it by user partitioning, so to speak, or user ranges. It eliminates the need for that necessarily. And you don't need a checkpoint table at all. These are all communicated directly between the two. So no more checkpoint table at that point if you're using the fully integrated capture and Replicat. Some of the benefits in the Replicats, the parallel apply, eliminates your range, trying to figure out how many ranges you need to get best distribution. It'll automatically scale parallelization, and you have some control over the minimum and maximums. Their process is direct transactions, barrier weighting. Basically, it'll know when it can apply a DDL if it's waiting on prior transactions to commit. It handles the duplicate key updates better, and also introduces, as part of the 10.204, all these Golden Gate views, which you can see are part of the parallelization process, where you can see how many records are being received, how many are read, how many servers are applying the changes, and you actually get the stats at the table level, where it'll actually tell you inserts, updates, deletes, collisions. All the CDR columns will all be populated in that table. So it's a great table for transactional, like tracking the history of that. The other great thing is getting rid of the DB user ID login, where you have to encrypt the password. You now create a credential store, and you add a user to the credential store, and now you log in with an alias that you use for that credential store. So no longer do you need to put all that information in the parameter files, nor specify it on the login with the command. So in the parameter files, you remove the user ID, password, encryption stuff, and just replace it with user ID, alias, and whatever alias you gave it when you created the credential. It reads it directly from a file that you can see that's stored in a CRD directory. And the process of doing a Golden Gate 12c upgrade, this is somewhat high level, but basically once the installation was done, replaced the DB login with the user ID alias, added a parameter for supplemental logging, and started the extracts. Not much else was required or needed to make any changes, so you can immediately shut down 11, bring up 12 with a few changes, and start capturing. Also, you'll get new messages written to the alert log now. These are the ones where it's doing the parallelization, but you can also see that it uses the use of tags now. So this apply tag 00, it tags all the records now so that you can use this in bidirectional to filter out and exclude things. So you don't have to exclude a user anymore, you can exclude tags. So there's some nice features there, but you can see some of the things it puts inside of your database alert log now. And it'll put these in every time it starts up and every time it shuts down. Some of the tips that we've seen or applied at client sites is excluding intermediate tables. You know, instead of wildcarding everything and capturing, logging everything and shipping everything and then excluding it, exclude those right from the beginning. You know, if you're creating tables for temporary processing and at the end you truncate and do something else with it, you don't need to replicate all that data over, so you should be excluding those. Sequences, if you're going to do the live standby, you should include your sequences so at least they're updated over on the live standby site. Again, sequences aren't supported bidirectional, but you want your live standby to at least have the highest value as your primary. It's also recommended that you create a different user for your extract and replicats. There is an actual MetaLink document out there that under some supplemental logging issues for that replication between source and target, if the extract is actually not running when it happens, your exclude user doesn't catch some of these things. Again, it's like a bug in a document. But if you use different users, then you won't run into that issue. Use the schema tran data when you can. Highly dependent on the version of the database you're at. You need to be at least 11.2 something. You can't, like 11.2.1 or 11.2.1, I believe, doesn't support it. You need to be higher than that to get it, 11.2.0.2.3. Use the batch SQL if you can. Not all cases of batch SQL and give you the performance increase, but there are cases where lots of transactions operating against the same records. It can have a performance improvement. And most people don't use it, but you can actually use insert append. You're using a unidirectional reporting database. You don't care about logging all that. You want that append hint for the insert. You can insert the append hint in your parameter file. Again, we mentioned that. Create your heartbeat if you want to monitor end to end. We recommend not putting, I think the MetaLink document references just creating a heartbeat table in one schema. We like putting heartbeats, including in every extract or replicat process, so that you can embed on heartbeat in amongst all your other transactions. So it kind of gives you a better DML stats on the other end if you do that, rather than just having a standalone table replicate over using its own replicat and extract. It really doesn't tell you much about how an individual replicator process is doing. So we kind of embed them everywhere. Golden Gate logins, they get generic names in the module and $$ session. You can actually control that or change that if you just make a SQL exec call at the beginning of your replicat file. So as soon as you log into the database with your user ID alias or user ID, make a SQL exec call, and you can call now set the module to whatever you want. So kind of handy if you're going to do looking at $$ session, looking for certain things. You can specify a name in there to where you can see it. Also show up in all the AWR reports and things. Some common errors and warnings that we've seen that are easily fixed. I don't know how many times people are used to SQL Plus and they run commands and they put the semicolon on the end of the line for the command line interface, and you'll sit there like 4 or 5 times trying to figure out what's wrong with it before you realize the semicolon's the problem. Syntax errors, it's easily overlooked. In this case, a map statement with an exception handler, and the comma was missing. What's interesting is it's never reported as a problem. If you look at the report file, you'll see where it actually mapped to the exception handler and did nothing. And so this actually took a few minutes to actually figure out, after going through and figuring, is there anything wrong with the exception handler? Is there anything wrong with the table? It turns out it's just a missing comma. These kind of things will really get you when you're having complex map statements. It's very picky on spaces in some cases, commas, things like that. You can spend hours trying to find one little syntactical error. Other issues are map and target statements not in the correct order, especially when wildcards are used. You can have duplicate mapping statements, and if you got them out of order, one mapping will take precedence over the other, depending on if it's an exception handler or not. So you want to be on the lookout for that. You want to be on the lookout for rep error statements that actually handle conflicts without you ever knowing it. So it's easy to put in a rep error statement to ignore a unique constraint error, but then it can actually handle it and you'll never know about it. So there are cases where you might want to report those as well, and then actually take some action based on it. Like, you shouldn't be getting you need constraint errors if you have especially in a unidirectional system. Statements added to the parameter file that apply to all maps when only one map is intended. Again, this could be like a rep error, or it could be an insert missing updates where they stuck it in the parameter file and now it applies to every single map after that. You have to either put it in, it's best to either put it in the map or put it right before the map and reset it right after the map so that you don't affect your entire Replicat file. Fix the simple warnings. There's warnings if you, every time, every Golden Gate installation I've seen starts up with no change, always get an NLS line character set different on source database. If you just set the environment in the parameter file, you can at least eliminate these erroneous warnings. And that concludes the presentation. If there's any questions, I can take questions now and open it up to everyone on the seminar. Again, if you're not on 11.204, there are some good reasons why you want to be, especially if you're going to plan on upgrading to Golden Gate 12C. In the 12C, I found that the parallelization makes a huge impact. And we're talking a 30-minute file. The Replicat took 30 minutes to apply, went down to 9 minutes with the parallelization. Very little change, just basically creating your extracts and stuff, alter them to be integrated. In fact, while we wait on if there's any questions, I'm going to show you an example of that. So I have just a shell script that does a SQL loader, and it's that 509,000 records. And you can see this is how fast it's inserting on the source. If we go over to the target, I'm in the target here, and I do a count, I'm 134, this is 100 and something. So it's not lagging that far behind. And we can see here when it actually finishes in a few seconds here, how much of a lag there is between the source and the target with record counts. So source should stop at 509, and on the target we're already at 479. I noticed with the parallelization it does take a little bit, like a few seconds longer on the tail, the very last commit, and I guess it's shutting down the parallel process and all. You can see it's caught up already. And some of those views that I told you about, you can look at, is you can actually look at the servers. And in this case, we had 1, 2, 3, 4, 5 different processes, actual messages applied, and you can actually see some statistics about it. If we start at the very beginning where it's receiving data, in this case, we see we're idle, we're waiting on a message. The readers, there's one reader. You can actually see transaction IDs and also you can see how much memory it allocated. So for that, the stream's pool size is 409 meg. I've set it to 500 meg on this system, and we use 409 of it. If that is too small, it'll drastically slow down the process, and you'll see messages for the process is saying waiting on memory, where it's actually trying to grow memory. And here's some additional high water marks, startup times, things like that you can get. But the big one, I think, is from the table one. So if we look at the table, we can see 1, 2, 3. There were 4 processes that did this load. You can look at the inserts for each right here. They're pretty well distributed. It does a pretty good job with that. And of course, there's no errors or conflicts with this. This was all inserts. But had you had updates or deletes or collisions, they would all be reported here. Great performance thing. One of the things I wanted to show you here is what happened when I loaded. Those 500,000 records built this 31-row table of the dimension. This is one of the things we saw in the previous slide where I built a dimension. This just built a date dimension on the fly from the raw 509,000 records. Same thing on the origin. It built this origin dimension. So you can see basically every city state that flight occurred within that particular month. So it's pretty powerful, some of the things you can do with it. 12C, definitely a big performance increase. Okay, I want to thank you for attending the webinar. If you have any questions, feel free to email directly. This presentation will also be posted up on our YouTube channel for if you didn't get a chance to watch the whole thing or want to pass it along to somebody that wanted to watch it. It'll be posted there within probably this week or next week. That concludes the webinar. I want to thank you, everyone, for your time.